What's wrong?
It's so.
Oh yeah. Well, we're getting to it.
It's so unfun.
We're getting. All right. So you should have picked up new note packet and cover sheet. Again, how you organize your binder is up to you. I would put Unit D on top though, because that's where we're going to be working out of right now. And then so that you have it right there at the top of your binder when you open it up, it's right there for you. Those of you that weren't here yesterday, you have a test to take. If it's not in your resource room, then it's in the Math Resource Center. Okay. So if you weren't here yesterday to take the test, make sure you get that done as soon as possible. Okay. For me, I can't say for Mrs. Hill, but for me, my grades are in and on the student portal, on the Infinite Campus portal. You probably even got some of you probably got a notification last night if you have the app that grades were updated and entered and all that fun stuff. So that's all there ready to go. We'll get those back we'll probably wait until tomorrow. No, probably Monday. It's easier to hand it back in grading phases. Okay. Okay. So today we're going to start talking. We're going to start this new S word right here. Yes, we're going to start solving today. Okay? So we're going to solve some equations today. Okay? So let's dive into it. Here we go. We are on the first one, D1. All right. So at the top of the page, we got a little warm-up area. So let's warm it up with these 6 quick ones. If you need to have out your multiplication chart, you can have that out, but go for it. Figure out these 6 different things with 6 and 2. For number 1, what do we get? -6 plus 2.
-4.
-4. I love it. -4 for that one. Okay? Because we're at -6, and adding means we're going up on our scales that are on all of our desks, or our number lines that are on our desks. So if we go up 2, we're at -4. Love it. -6 minus 2 in number 2. -8, because now we're starting at -6, but we're subtracting, so we're going down on that number line. So that one's going to be -8. Okay. Number 3, positive 12. Why positive? Same signs when we're multiplying, that's a positive. Yes. Okay. All right. What about number 4? -12, because now the signs are different. Okay. So we've got that. -12. Ooh, now here we go. Number 5. 6 divided by -2. -3, because the signs are different, so that's why it's negative. And 6 divided by 2 is 3. Love it. Okay. So -3.
Just a quick sneak peek on number 5. Why we got decimals?
Man, why? I know, I get it. I hear you. What about number 6? -2 divided by -6. +3? Do we agree with +3? Nora, you got something? You got a little not like you don't agree look on your face.
It's -3.
Okay, hold on one second.
I'm bad.
Oh, you just got that problem? Okay. Does everybody agree with what you said, +3?
Yeah.
I like the positive part, because negative divided by negative, signs are the same, makes it positive. That's the only part of that I like. Yeah. So what do we got?
It's negative.
Positive 1/3, yes. Okay? Which is different than 3.
Oh, I thought we were
Okay.
5 still. I got 6.
Okay? Alright? So it's positive 1/3. The negative divided by negative makes it positive. 2 can be divided by 2. And 6 can be divided by 2. So that could be positive 1/3. Okay? Love it. Apparently it's not on this one. Okay? Come on. Go to the next page. There we go. All right. By the end of this unit, hold on. That should be unit So by the end of unit E, so we're starting unit D right now, okay? So, but by the end of unit E, that's going to be a problem that we're going to solve.
Yeah, $5.
No, we're not going to try it right now.
Can I try right now?
Yeah. Well, you got to write it down then if you want to solve it on your own. Yeah, go ahead.
That up.
But we're going to, you know what I mean? Okay? So in order to solve this equation, you are going to have to learn to show your work. There is no way that you can do this, solving this equation all in your head. Okay? If things will get just mumbled, jumbled, and all kinds of craziness. Okay? So you are going to have to get into the habit of showing your work. Okay? On all of the Unit D and all of the Unit E homeworks, it says no work, no credit. Okay? So you got to show all of your work, and we are starting that today. Okay? That we are going to be showing all of our work from now on. Math is all about showing our work. Okay? All right. So here we go. Let's start filling in some words. The goal of solving an equation is to get the variable. What do we think?
Alone.
Alone. Yeah, that's a good word. Alone. Let's see. Winner, winner. Chicken dinner. By itself, same thing. Okay, get the variable alone or get the variable all by itself. Okay. Typically in math, we use x as our favorite variable. Okay. So we would want to get our equation to be x equals some number or some number equals x is what we're looking for. Okay. Okay. Oh man. This is the big one. We should even quote what? Got the break. Let's go creative pen. We want stars because this is an 8-star line right here.
You gotta do the same thing on both sides.
Okay? You gotta do what?
Same thing on both sides.
The golden rule of algebra says that whatever you do to one side of an equation, you must do that to the other side of that same equation. Oh, I did it not. One little right there. Okay. That is huge. Okay. There are people in my Algebra 3 and pre-calculus class that sometimes forget this. And then they wonder why they got something wrong. Okay. Whatever you do to one side of the equation, you've got to do to the other side of the equation. That's the break. We'll get that. Okay. Just wait on it, man. Okay. All right. Now, when we're doing this, whatever we're doing on one side of an equation, we need to think opposite operations. Okay? So my question to you is, what do you think the opposite of addition is? Subtraction. What's the opposite of subtraction? Addition. Okay, so those two are opposite operations. Okay? Give me another pair of opposite operations. Division and multiplication, yes. So if we are dividing something in our equation, to move it to the other side, we're going to have to multiply. If we're adding something in our equation, to move it to the other side, we're going to have to subtract it. Okay? We got to think oppositely when we're dealing with moving stuff from one side to the other. Okay? So the opposite operation of addition is subtraction, and the opposite of subtraction is addition. Opposite of multiplication is division. Opposite of division is multiplication. Okay? We'll just okay? So, if we are solving, remember, we want to get this variable. So you first got to figure out what your variable is. And right now, our variable is x. we need to get that variable all by its lonesome on that side. Okay? So if I'm looking at this side of the equation, I have a plus 5 over there that I need to move. So what's the inverse operation, or the opposite operation of addition? Subtraction. So I am going to have to subtract 5 from both sides. Now, if it helps you, okay, some people do this, where they draw themselves a line through the equal sign, because that signifies the two sides of your equation. Okay? So if I'm going to subtract 5 right here on the left side of my line, I also need to subtract 5 from the right side of my line. Have to do it on both sides, because that's what the golden rule of algebra, which should have 8 stars by it, says to do. Whatever we do on one side of the equation, we have to do the same thing on the other side. Okay? So what is positive 5 minus 5? Positive 5 minus 5. It's 0. Okay? Right? Which means it goes away. Okay? So what's left on the left side of the equation? What's left is just x. Okay? On the right side of the equation, what is 9 minus 5? 4. Okay? So I get 4 on the right side of the equation. Now, here is the most important part of the whole process. What should we do now? Is there any? Because we're done, right? So there's 2 things that we have yet to do in this problem. One of them should happen before the other. Okay? We don't need to rewrite it, no, because it's already written for us. Okay? The first thing that we should do after we're done is we should check our work. How do we go about checking our work? No. What we're going to do is, remember, our original equation was x plus 5 equals 9. We're going to take and we're going to replace the variable with our answer. Okay? We're going to plug our answer back into the original equation. Okay? So if I replace x with 4, because x is equal to 4, now this becomes 4 plus 5. Well, what is 4 plus 5? 9. And is 9 equal to 9? Yeah. Okay? So we checked our work to make sure it was right. Now, the better you get at it, the more checks you do, the faster you'll become at it. Okay? So that it might take 10 seconds for you to check your work. Okay? And the nice part about that 10 seconds is you know if you're right or not. But algebraically, we got to do it this way. Because they're not always going to be this, one-steppers. Tomorrow we're going to get into 2-step equations. Okay? Right? Okay? So we checked our work. That's the first thing that we do when we're done. What do you think the second thing we're going to need to do when we're done is?
Go to the next problem.
Nope, not yet.
You already checked the answer.
Yeah, but what's the second thing? To make it easier on your teacher so your teacher doesn't get mad. We're going to do what? If there's an answer blank, we're going to put it there. What if there's no answer blank? We're going to circle it. Yep, we're going to put it. We're going to make it so that other people can see our wonderful work and that we can actually do something with it. Okay? Okay? Because we're showing more work, so we don't have just the answer there anymore. Okay? So we need to distinguish or identify our answer so that we can see it. Okay? Don't worry about it. Yeah. All right? So now let's go on to number 2. Now, Jake, now that we've did our work, we've checked our work, and we've circled our work because we're proud of our work, now we can go on then to the next problem. Okay? So the first thing is we got to do our work. Okay? So again, if you need to draw yourself a little like dashed line right down the middle to distinguish between the left and the right sides, you do you. If you are above that, that's fine with me too. Right? I don't care. Okay? That's just a little helpful trick that we have in the mathematical world. Okay? What's the variable that we need to get by itself? Y is the variable that we need to get by itself, because remember, variables are letters. Okay? What is being done to Y? What is the mathematical operation that's attached to Y? We're subtracting 3. Okay? So what is the opposite operation of subtracting 3? Add 3 to both sides. Okay?
Too many steps.
So far it's been 1. Okay? Okay? Left side, y minus 3 plus 3. Y minus 3 plus 3. That's just y, right? Yep. Because the minus 3 plus 3 is 0. Yep. So the left side just becomes y
equals 15.
equals 15 on the other side. Okay? So now we have to do what? So we did our work. Now we got to check our work. So we're going to plug in 15, and we're going to subtract 3, and hopefully that's 12. Now, you may be saying to yourself, Linz, why are we doing this? This is so dumb. Why do we have to check our work? Okay? Right? The reason is, again, tomorrow we're going to have multi-steps, and we're going to get on, and we're going to keep going. And we're going to have more and more and more and more steps to do this. And the chances of you making a slight mistake, you forget a negative sign, your whole problem is off after that. Okay? All right? And you'll find that in this check step. Okay? 15 minus 3 is 12 equal to 12?
Yeah.
Yes. So what's our last step we need to do? We need to circle our answer because we're proud of our work. Okay? All right?
Come on, Don. Let's hit the video.
Ooh, number 3. What's the variable that we need to get by itself? D is the variable. What mathematical operation is being performed onto D? Multiplication, right? We're multiplying 2 times D. Okay? What's the opposite of multiplication? Division. So we're going to have to divide by 2. Okay? 2 divided by 2 is 1. 1 times D is D. Okay? Alright? So we've got D here. Negative 10 divided by 2.
Negative 5.
Negative 5. Okay? Now, we need to check our work again, right? So we've got 2 times negative 5, and we hope that that is negative 10. 2 times negative 5. Is it going to be positive or is it going to be negative? Why? Because the signs are different. Yes. Okay? 2 times 5? 10. So our answer is negative 10. Is negative 10 equal to negative 10? Yes. So what do we need to do last? Be proud of our work. Circle our answer so that somebody else can see, look, I did that. Okay? Now, here's the crazy one. Number 4. So first off, what's our variable? W. What's our mathematical operation? Division. Okay? So what's the inverse or the opposite of division?
Okay.
Multiplication. What am I, Jake, who's talking? No, you are, and it's really annoying because I'm trying to teach, okay? What are we gonna have to multiply both sides of our equation by? 4, because whatever I do to one side, I gotta do to the other side. So I'm going to multiply this whole side by 4, and I'm gonna multiply that whole side by 4. Okay? Now, left side. What does the left side become?
Wow.
Left side? Because really, on the left side, what we're doing is we're doing 4 times W divided by 4.
Yeah,
So it's just W. Okay, because the 4, we got a 4 on top, we got a 4 on the bottom, they cancel each other out. So we're left with just W. 3 times 4. 12. Checking our work now, we would have 12 in place of W. We would divide that by 4. 12 divided by 4. 3 is 3 equal to 3? Yes. Okay, so then we can do circle, box, put stars by, be proud of our work. Okay? Flip the page over. Here we go. You now try numbers 5, 6, 7, and 8. Okay? We'll save number 9 for together.
Number 9.
But do 5, 6, 7, and 8, please. First one. Tell me, actually, well, really, it's the 5th one. Tell me what I should do to get G by itself. Chad, what should I do to get G by itself? Add what? 2.3. I'm going to add 2.3 because 2.3 is being subtracted. So I'm going to add 2.3 to both sides. Okay? Negative 2.3 plus 2.3 gets me 0, plus G just gets me G. Okay? 3.6 plus 2.3. 5.9. Okay? Now, when I go to check it, I'm going to go 5.9 minus 2.3. Because order doesn't matter in addition, and that hopefully is going to be 6. 9 minus 3 is 6. The decimal point stays in the same spot. 5 minus 2 is 3. 3.6 is equal to 3.6. So that is my answer. In number 6, what's the operation that I'm going to do to get X by itself? In number 6. I'm going to multiply both sides of my equation by 5. Oops, that was bad. Add parentheses. Multiply by 5 there. Multiply by 5 there. Okay? 5 times X divided by 5. Just X. Negative 10 times positive 5. Negative 50. My check, I'm going to have negative 50, and I'm going to divide that by 5, and that's going to hopefully be negative 10. Negative 50 goes into, or excuse me, 5 goes into negative 50. Positive, or negative divided by a positive, so it's going to be negative, so that works. 5 goes into 5 one time, and then the extra 0 makes it be negative 10. Works out, circle, box, Number 7, what's the mathematical operation that I'm going to do to get x by itself? So I'm going to subtract 6 from both sides. Negative 11 minus 6. Do we agree with positive 17?
No, we don't.
Okay, what should it be? I like negative 17 better. You added 6. That's how you got 5. Yep. Yep. Then, checking it, negative 17 plus 6 is negative 11. That works out. So we've got negative 17 there. Okay. Operation that I'm going to do to get rid of the negative 3 attached to the k. I'm going to divide both sides by negative 3. Negative 3 divided by negative 3 gets me just k. Positive divided by a negative is negative, so my answer is going to be negative from the start. 9 divided by 3. 3. So my answer here is negative 3. Checking it. Negative 3 times negative 3, hopefully, is positive 9. Negative 3 times negative 3 is positive 9. Yes, so negative times a negative makes it positive. 3 times 3 is 9. Love it. Okay. Eric paid. So now we got these little quick word problems in here. Yes. Okay. So there's a couple of things that we need to do in a word problem. The very first thing that we need to do in a word problem is we need to read it. Okay? That's the first thing that you got to do in a word problem. You got to read it so that you figure out what you have and what you need to find. Eric paid $84.39 for a winter coat, which was priced at $79.99. Find the amount of tax he paid. So let X be, we know the final bill that he paid at the register. We know the original price. What don't we know? The tax. So let's let X be the tax paid, because that's what we're looking for. Okay? So the first thing that you're going to do after you read it is you're going to define what the variable is. Okay? So X is going to be the tax that he paid. Okay? Then you have to come up with an equation. Now, most of you have probably been to a store at some point in time and you've actually bought something. Okay? So if I go to the store, I see something on the shelf, I grab it, I walk up to the counter. What do I pay in the end? I pay the amount that the product was worth, right? Plus the tax, right? That tells me what the final bill is. Okay? So what was the original amount? $79.99. Then I have to pay what? I have to pay tax, right? What am I going to represent my tax as? X. And all told, I handed the cashier how much money? $84.39. What was that? Because we don't need the dollar symbol in the. Try that the next time you go to a store and just say, "Hey, how about we forget the whatever the the cents are?" We'll see how that works out for you. Okay. All right. So how am I going to solve this problem? What do you got? Talk to me. So I'm going to subtract $79.99 from both sides. Okay. All right, let's do some old school subtraction here. Yes. 9 minus 9. That's going to be 0. I like that one. 3 minus 9. Ruh-roh. Can't do it, so what do I got to do? I got to borrow from the 4. So I'm going to borrow 1. That makes this 3. What does this become then? 13. Love it. 13 minus 9. Now. 4, right? 4. What about that decimal point? That thing moved? The decimal point moves? No, yeah, it just stays in its column. Okay. Now I'm stuck again with a 3 minus 9. Take away from the 8. Okay. So if I take 1 away from the 8, that makes that 7, which would add a 10 to that one. 13 minus 9 again is 4. And 7 minus 7? 0. Okay? So my solution is x here is going to equal $4.40. Now here, we could add back in the money symbol because in word problems, we like to give our answers with labels. Huh? With me? Love it. Okay, so what I need you to do right now, we're going to do a quick activity because I really wanted to get to it. Okay? What I need you to do right now is I need you to find a partner and push your desks together. Go. Do that now. Go. Go. Go next to your partner. All you need is a writing utensil with you. Go. What? You cannot do a group of 3. One person's going to have to be with me because we're in an odd number. You going with me? Okay. You can here. We'll sit here. You can sit in my chair. Yep. You run as much as one. Gotta be in desks. Gotta be in desks. Gotta be next to one another. Push your desk next to one another. Go. Cannot be in a group of 3. Okay. Okay. Next, what I'm going to do is each of you is going to get, listen now, so that you understand. Each of you is going to get this purple piece of paper. You can just grab one right there. Okay? So each of you gets your own. What you're going to do is you're going to pick 5 values from the blues, and you're going to set them equal to 5 values from the reds. Okay? So you're doing 5 values from the blues, setting them equal to 5 values from the reds, and you're going to put all of those on your paper. They're going to be different. You're going to put all of those up on the top half where it says equation. Okay? Here's the blue group, here's the red group, okay? So you need to make 5 equations in equation number 1 box, equation number 2 box, 3 box, 4 box, and 5 box. Go now. Okay? So you made your 5 equations, now we're in the switching and you're solving. And then you're going to switch back and you're going to check your partner's work.